All right, so we're going to graph square roots, and we kind of started this yesterday with that sailboat question, but we're going to graph each function on our paper. What is a parent function? What is a parent function? Parent function is a parent, okay? So it's kind of like, notice how you're born from your parents, right? Like you're like a replica of their DNA, right? I like that. Yeah. So this is the base function, and then other functions are the offspring, right? Okay. So this parent function is really kind of our foundation for radicals. There is this transformation directions. So if you have a negative underneath the radical, you're going to move h units. If you have a plus sign, you're going to move left units. If you have a number outside of the radical, you're going to move up that many units. If you have a minus that number, you're going to move down that many units. And if you have that negative, it's going to reflect over the x-axis. Okay, and x-axis is right in here. Okay, so if I had a negative square root of x, that'd be like chilling down here, right? Look at that terrible graph. Okay, I'm never going to ask you these types of questions solely because there's not an AKS that says that you have to learn transformations in here. However, they're expecting you from like geometry to be able to understand transformations. Okay, so it's kind of like catch-22. They might ask you a question that's like, hey, how is this function different from this function? But they can ask it in key features terms, like how are the domains different? Okay, so when we're looking at this one and we want to graph it, yesterday, how did we start our graphs? What did we use? A table, right? Okay, so I'm going to take some x values. Somebody give me some x values. Okay, 2, 3, 5, 6. Baron's trying to make it difficult on us. All right, and I always like to do 0 in here as well, just because it, I want to see where it hits the y-axis, right? So 0, 2, 3, 5, 6. I mean, he's the only one talking. All right, so I'm going to put 0 into this equation, okay? So I'm going to put 0 into this equation. So if I put 0 in for this x, what's the square root of 0? That's 0, right? And then 0 plus 5 is going to give me 5. So I'm going to have a point at 0, 5. I would write this chart on the side. I would write this table on the side because when you try to graph this stuff, you're going to graph like accurate points. Okay? All right. So now what we're going to do is we're going to plug in 2 into this equation. Okay? Notice how it's square root of just 2. Does that make sense? It's just the square root of the number that you're plugging in. Okay, so you're going to get what? 6.4, okay? All right, if I take 3 and I plug it in, I'm going to get the square root of 3 plus 5. So what is that going to give me? If I plug in 5, what's going to happen? If I plug in 6, what's going to happen? Be like that sometimes. Go ahead and plug in when x is 1 so that we can see that graph really well. When x is 1, what happens? 6. Okay. All right. So now I'm going to actually graph these points. Is everybody caught up? Does everybody understand why I created that table? Okay, so that table is allowing me to have points that I'm going to graph on my graph. Okay, so you can always create a table from an equation, which will give you a graph. Okay, so now I'm going to plot 0, 5. So I'm going to go up to 5. 2, 3, 4, 5. I've also got 1, 6. So I'm going to go to the right one and up to 6. I've got 2, 6.4. So I'm going to go right 2 up to 6.4. And 6.4 is going to be like in between 6 and 7. It doesn't have to be completely exact because like you're hand graphing this. 3 comma 6.7. So I'm going to go over 3 and up to 6.7. Right 5 and up 7.2. And to the right 6 and 7.4. Notice how I always, when I start plotting my points, I start from 0, 0 again. I go back to 0, 0 and I say, okay, how many units over? How many units up? And you will see me do that every single time. Did I skip a line? 1, 2, 3, 4, 5. Yeah, I did skip a line. Where it at? 1, 2, 3 should be 6.7. 6.7, which is right here. And then 4 would be right here because Baron messed it up. And then 5 comma 7.2 and then 6.7.4. So when I connect all these, it's going to look like that. And you want to make sure that you put that arrow on the end because that continues on forever, right? All right, so for transformation, what I want us to look at is your parent function. Okay, so looking back at the parent function, this guy right here, okay, that's on your paper. That square root of x. What happened between the square root of x and the square root of x plus 5? It went up 5 units. Okay, and again, this is technically not a requirement, but I've seen it in my days where they ask questions that are like, hey, you still have to know the transformations. So if I take, I'm recording, I'm in the studio. Okay, so if I take 0 and I plug this in, your calculator is going to be like, hey girl, you got an error, okay? Or hey dude, you got an error, okay? And if I plug 1 in, I'm going to get 1 minus 2. Well, that's going to give me a negative 1. That's a not real solution, right? Yeah, I'm positive. So you're going to have another error right there. Okay, so you're going to put 2 in here, and you're going to get 2 minus 2. What does that give you? And the square root of 0 is, oh my god. Okay, so it's going to be 0. And then you're going to plug 3 in. And 3 minus 2 is going to give me 1. What's the square root of 1? Is 1. Baron, you... Okay, so 4 plugged in here. 4 minus 2 is 2. What's the square root of 2? Oh my god, you're confusing everybody. Alright, so if I plug 4 in here, what do I get? 2. What's the square root of 2? 1.4. Okay? If I plug 5 into there, I'm going to get 5 minus 2. That gives me 3. What's the square root of 3? 1.7. Alright, and let's go ahead and do 6. So if I take 6 and I plug it in, you're going to get 6 minus 2. That's going to give me 4. What's the square root of 4? 2. Okay? So now I'm going to plot this junk. All this error stuff, like we leave that off our graph, right? Like it's not a thing. So now we're going to do 2 comma 0. That means I'm going to go to the right 2 and plot that point. I'm going to go to the right 3, go up 1. I'm going to go to the right 4, 2, 3, 1, 2, 3, 4. And then I'm going to go up to 1.4. I'm going to go to the right 5 and go up to 1.7. And then I'm going to go right 6 and go up to 2. And I'm going to connect that junk. Why do I connect that? Alright, so now we're going to look at the transformation stuff. So how did this change from the parent function? What happened? It moved which direction? Which direction? Right 2 units. I just worked it. How did it move right 2 units? Okay, so remember our parent function looks like roughly that, okay? And then from here to here, there was 2 units moved. Parent function is that square root of x. And if you're ever like unsure of what it looks like, you can put it in your graphing calculator and it'll graph it for you, right? Okay? Yeah. Okay? Cool? Alright, so go ahead and try number 3 and then go ahead and try number 4 because it's the same thing as what we just did. Yeah.
I ain't never seen it before.
You got this. I believe in you. So over here on the left-hand side, we put this XY table. And some of you might have picked different numbers, but for right now, we picked 0, 1, 3, 4, and 6. And I would normally try to number your numbers. Put your numbers in sequential order. Listen, it's rough. It's Tuesday. Okay, so when I plug these numbers in, this is what I'm going to get. Okay. And then when I plot them, I'm going to get 0, 2, 1, 2.2, 3, 2.6, 4, 2.82, and 6, 3.16. So this mess is going to look like this.
I didn't go.
So what's wrong with this graph though? Well, there's that. Well, we went up. So what did we do wrong? I mean, is it supposed to go to the right, Olivia?
Yes.
It's supposed to go to the left, right? Okay, so let's plug in. Ready? Shh. Let's plug in -4. Let's plug in -4. When I plug in -4, you ready? You ready? Shh. Wait for it. I'm gonna show you. Okay, so -4. I'll plug it in, and I'm gonna get -4 plus 4. What is that gonna give me? 0. What's the square root of 0? Okay, so I'm gonna have a point at -4, 0. So where does this graph actually go? All the way over here. Okay, so did it move left or right? It moved left, right? Haha. It moved left, correct?
I got it wrong.
No, you just need to add one more point. So that's a good question. Is he wrong on his graph? No, he's not, but he just didn't extend it all the way to the left. And that could make the difference if you did not know your transformations. Does that make sense?
Yeah.
Okay. What numbers did you use, P2?
I used 3, 6, and 9.
3, 6, and 9. So he's going to see this part, okay? But he may not see that shift to the left, right? Okay? So that's why we want to make sure that we know those transformations so that we can tell the difference between those two. Okay? Huh? Until like 8:30. Say that again? Move to the left 4. Okay? Because that plus 4 under here, underneath the radical. Yes, ma'am? Okay, so on number 4, we're still going to create that XY table. And we're going to use numbers like 0, 1, 3, 6, and 9. Okay? So I'm going to plug in 0 into my equation. I'm going to get the square root of 0 is 0 minus 6. Okay? Notice how this square root stops over that x. So we're going to get -6 right here. We're going to take the square root of 1 because that's the next number we're going to plug in. Square root of 1 is 1. 1 minus 6 is -5. Square root of 3 is what? So now I'm going to plug in 3 into this radical. What's the square root of 3? Okay, so 1.7 minus 6 is what?
4.26. -4.26.
If I take 6 and I plug it into the square root, I'm going to get square root of 6 minus 6.
-1.5.
Negative what?
-1.55.
Okay. No. Square root of 6 is what? Okay, and then 2.4 minus 6 is what? Say it again. -3.6. If I take 9 and I plug it into that square root, what's the square root of 9? 3. 3 minus 6 is -3. When I plot these points, I'm going to get 0, -6. 1, 2, 3, 4, 5, 6. 1, -5. 3, -4.2. 6. Okay, that's good. 4, 5, 6. -3.6. 2. 1, 2, 3.6.